Surrey Space Centre really has pioneered small satellites for science, for communications and Earth observation, and indeed now navigation.
We are investigating missions where we are trying to address today's problems in a way affordable for society.
There's a growing problem in space with debris. Surrey Space Centre is leading the way with active debris removal demonstrations.
We support the next generation of engineers. We have to be creative and we have to sustain innovation in space.
The Surrey Space Centre was formed in the late 70s here at the University of Surrey in the UK, and the initial idea was to try to explore cost-effective technologies for space activities.
We've had a small team of researchers who got together and built our first satellite, USAT-1, the first satellite launch in 1981. That was essentially the formation, the beginning of the Surrey Space Centre. Step by step, the Space Centre grew with research students and research staff focusing on how we could use commercial off-the-shelf components to build small but very capable and inexpensive microsatellites.
Today we have continued along that path to produce cost-effective technologies and cost-effective answers to new problems. The Surrey Space Centre has a capability to be able to put together missions from the early concept design down to building the hardware, then launching and operating in space and using the data for applications useful for the community.
We work on a whole variety of projects at the SSC, and this can be anything from radiation detectors throughout things like deployable optics. If you can think about a project that might be interesting for space, we're probably working on it.
Here at the Space Centre we can tackle a range of projects, from the very small student projects up to our largest projects have a budget of around, let's say, 15 million. What we try to do throughout our projects is to find different ways in a cost-effective manner to resolve a particular issue or a particular problem.
Space debris represents a hazard to all users of space. Removed debris is going to be the first time that there's been an attempt to demonstrate active debris removal in orbit.
Our mission, Remove Debris, that is sponsored by the European community and also with partners around Europe, is aiming to demonstrate technologies that can be used to remove the most dangerous debris that are currently orbiting around the Earth.
The Remove Debris project consists of one large mothercraft that houses all of the experiments on board, and one by one the mothercraft will deploy the experiments and will operate the experiments in space, demonstrating capture, vision-based navigation and deorbiting techniques. We're going to simulate debris by use of a CubeSat, which will be ejected from the mothership, and we're going to use the camera to actually track the object and see how it moves. Next we have a net experiment. Again, we're going to deploy some debris, then the mothership will catch the debris, and all of this will be filmed using supervision cameras. Next we have the harpoon experiment. We're actually going to roll out a target and then fire a harpoon into the target. And the target's made to replicate the skin of a spacecraft which is already in space. Lastly, we're going to deploy the drag sail, and we're going to be able to track Remove Debris, the mothership, and we'll be able to see the change in its velocity and its attitude as it comes down as a result of deploying the drag sail. The Surrey Space Centre's role in Remove Debris is we are the consortium managers, but also we deliver several parts of the mission itself. So the CubeSats, the drag sail, and also part of the harpoon target assembly.
What we hope to be able to demonstrate is that this is actually possible to use these cost-effective technologies in order to do this for real and then going to capture real pieces of debris. The way we work at our projects is collaboration with other companies, research institutes around the world, like for example Airbus. Our main partner is the company SSTL that was actually formed within the Surrey Space Centre.
The Surrey Space Centre and SSTL really is an exemplar of academic and commercial synergy. The Space Centre undertakes long-term research into ideas, and when they are useful, then the company can pick up those ideas and put them into commercial missions.
As a university, it's really important to build these connections. It can provide students with a real novel opportunity to work firsthand with larger scale space organisations.
The Space Centre work with ESA, NASA, UKSA, because they work so well together from beginning to end of a project. It gets you involved in the entire process.
Our MSc students get the opportunity to interact with space engineers, and they derive the outcomes of their project based on the niche requirements of the space industry. Our postgraduate researchers, they also get the opportunity to work on real space missions, so they see how mission concepts evolve.
Surrey Space Center is a very great place to work in. We are able to work on satellites and to have very good top facilities for the job. I believe you can really grow and find your right path in the space career.
So the next exciting thing in space is going to be in-orbit assembly. We have a project running between SSTL and the Space Centre to demonstrate that in the next couple of years.
Surrey Space Centre is at the core of the future of space science because we're actually doing things in the space environment now, developing inflatable structures for space, deployable items for space.
Here at the Space Center, we help producing the technologies that will be useful for tomorrow, and at the same time we also help forming the future workforce that is necessary in years to come.